So we're going to talk about numbers today. Okay? Hopefully you guys already have the title down and the date. And as you were growing up, when you were a little tiny baby, right? What kind of numbers did you learn at the very beginning? Well, maybe not as a baby, right? But you know, as you grew up, what's the first type of math that you learned? 1, 2, 3, right? Counting, yeah? Counting. So maybe not as a baby, but let's say as a kid. These are my kids. As a kid, you started to count, right? We started counting, oh, I got 1 toy, I got 2 toys, I got 3 toys, yeah? So that was natural. That was natural. And what I would like you guys to do is go to the middle of your page, and I would like you guys to write down a little box. Let's write down, oh, this is going to be too small. Let me see. Give me a second. A little box at the center of your page, and we're going to use the whole page, so really go down to the center, write it as small as possible, natural numbers. Because that's how we learn how to count naturally. 1, 2, 3. 1 toy, 2 toys, 3 toys. So after that, after learning how to count 1, 2, 3, we learned about the number 0. Give me a second. We learned that sometimes you could have 1 toy, 2 toys, 3 toys, or sometimes you could get the toys taken away, right? And you have no toys. So that's the next group of numbers we're going to be talking about, the numbers involving 0. So what I would like you to do is to make a bigger box on the outside of this one, and let's classify this as whole numbers. Whole numbers. Now, what are whole numbers? It's the same exact thing as natural numbers. So you do have the 1, 2, 3, 4, 5, 6, but the only difference between whole numbers and natural numbers is the concept of 0. Okay, so whole numbers includes the number that has the biggest hole in it, the 0. Yay? Get it? Yes. Okay. So after that, we learned that when you grew up a little bit more, you learned that not only do you have toys, or you could get them taken away and you have nothing, but we also learned about money, right? And you have money and you could owe money. So that brings up the negative numbers, and those numbers are called integers. So I'm gonna have to mess with the screen here, but let me do the next box on the outside. Integers. Okay, and what are integers? They're -3, -2, -1, but it's also including the 0, the 1, the 2, and the 3, ... So it goes forever in both directions. Integers are those nice numbers like 3, 5, -5, -7, even including 0, right? So we have all these groups of numbers. And we grew up some more, right? And you realize that not all numbers are nice, like -3 and like +5. Sometimes you end up with fractions and decimals, right? Sometimes you end up with a -3.5, or you might end up with just 0.75 or 1/2. Those are called rational numbers. So make a bigger box around these guys and put rational numbers. Okay, now what are rational numbers? Again, decimals like 3.5, or like -1.5, or even like a fraction, 1/2 or 3/4. And those are all called rational numbers, okay? Now, in this case, or this next part, I'm not going to do a box around natural or rational numbers. I'm actually going to make a box, or an attached box over here to the side, okay? Because these guys are called rational, which, by the way, within the word rational is the word ratio, and ratio means fraction, and fractions are decimals. That's why rational numbers are fractions and decimals. And over here on the other side, we have irrational. Irrational numbers. I'll just put the number symbol save some time. Now let's take a pause right here and let's talk right here. In English, the word rational, what does it mean compared to the word irrational? Like let's say somebody's you turn on the TV, you're watching the news, and the news reporter saying, this person's having irrational thoughts on the top floor of this building looking over. What's that person thinking of doing? Jumping off. Irrational, right? That's crazy, right? As opposed to having a rational thought. A rational thought would be like, you know, it's a good idea to take notes right now. This is the first lesson, right? So that's rational compared to irrational. You guys understand that difference? Yeah? Okay. So rational, it makes sense. Irrational, it doesn't make sense. It would be irrational for me to just take off my shirt right here. That would be irrational, and I'll probably get fired, right? So that would be irrational. It's rational for me to continue with this lesson, continue with this video. Okay, so rational versus irrational. Rational numbers. Yes, ratio means fraction or a decimal. We see the 3.5, that makes sense. You guys understand that, right? 3.5 is 3.5, right? Or $3.50. Rational numbers, rational, make sense. Irrational numbers don't make sense. They're crazy. Can anybody give me an example of an irrational number, a crazy number? 4/3. 4/3? That would be 1.25, and I understand $1.25. Pi, definitely. Pi is stinking nuts, right? So let me do a pi symbol right there on the irrational side. Now, why is pi crazy? Because it's 3.14, and it continues forever, and it does not stop, right? It continues forever. It doesn't stop. There is no pattern to it. It's just a crazy number. It's an irrational number. What do you guys think of that? Make sense? A crazy number is an irrational number. Are we good with the square roots? Do you guys know what the square root of 9 is? 3. What's the square root of 25? 5. The square root of 64? 8. Okay. The square root of 4? 2. Perfect. What's the square root of 20? I need a calculator, right? Okay. You need a calculator. Because when you do the square root of a non-perfect square number, that makes it irrational. If you actually get a calculator and type in the square root of 20, it's going to be about 4 point something that continues forever. There is no pattern. It's a crazy, crazy decimal, and that's what makes it an irrational number. Okay? So like the square root of 7, let me scratch this out. The square root of 7, that's going to be irrational. The square root of 5 is going to be irrational. Pi is irrational. In algebra 2, we use the variable e. E is also 2.72, and it continues forever, and there's no pattern. That's also irrational. So what I want to do right now is look at this chart that we just drew and these notes that you guys have in your notebook. And let me ask you this. True or false? The number 0 is rational. True. Now some of us are thinking, wait a minute, the number 0 is a whole number. Yeah, that's true. But the number 0 is also rational. It makes sense. But when you say that 0 is a whole number, that's being as specific as possible, right? So how about this? The number 1 is rational. True, right? The number 1 is definitely rational. But that's like if somebody came up to me and I wanted to introduce myself, and I say, or they ask me this. So they say, where do you live? And I say, I live on the planet Earth. Okay, is that true or false? That's true, but it's not as specific as possible. That would be like saying the number 1 is a real number. Of course it's a real number, right? The number 1 is a real number. But if you want to make the number 1, if you want to say that, if you want to make it as specific as possible, the number 1, it is rational. The number 1 is an integer. The number 1 is a whole number. But if you want to be as specific as possible, that would be a natural number. The number 1 is natural. Make sense? Okay. So how about -5? Is that a natural number? -5, a natural number. Remember the story. You started growing up, you learned how to count 1, 2, 3. And then you learned about 0, 0, 1, 2, 3. And then you learned about 0, 1, 2, 3 with negative numbers. So -5 is not a natural number. It's not even a whole number. It's actually an integer. What do you guys think? Make sense? Yeah? Okay. pi is irrational. True or false?
True.
True. Pi is definitely irrational. Okay? So I hope this kind of helps on getting you to understand the different groups, the different classification of numbers. Again, if I asked you true or false, the number 2 is an integer. The number 2 is an integer. True or false? It's true. But if you want to be, if I say classify the number 2 and be as specific as possible, you don't want to just stop right there and say that 2 is an integer. You want to say that 2 is what? As specific as possible. It's a natural number, right? Okay? So 2 is a natural number if you're classifying it and trying to be as specific as possible. There's some math teachers that say list all the groups that the number 2 belongs to. So in other math teachers' classes, you would say, oh, the number 2 is an integer. Okay. The number 2 is a whole number. The number 2 is a natural number. I'm not going to ask you to do that. I'm just going to tell you to classify the number and be as specific as possible. Bless you.